minus x minus 2, or minus 5 over x minus 2 equals negative 20 over x squared plus x minus 6.
So this is from classwork, right?
Yeah.
Okay. So let's read it one more time. 6 over x plus 3 minus, I think it was 5
Yes.
over x minus 2 equals negative 20 divided by x squared plus x minus 6. Very good. Always remember, I post solutions. So if you still want to look at the solutions, please print them out and so on and so forth. Good. So what type of equation is this? So the questions that I'm presenting or posing to you are the same questions that go through my mind if you throw this at me like you did. These are the questions that go through my mind. First of all, I'm asking myself, what is it? Because if I say it's an absolute value equation, I'll never be able to solve it. If I say it's linear, I'll never be able to solve it, right? So what is it? True, wise, but specifically what?
Irrational.
Of course, it has ratios and it has x in the denominator. Very good. It is a rational equation. Then I'll say to myself, okay, I think I want everything on one side. So 6 over x plus 3 minus 5 over x minus 2 equals, and I want to answer, a student asked me, is this negative 20? Is it negative in the denominator? Of course not. If you put negative here, then you're changing into positive. So a negative number over a positive number is negative 20 over, and I will factor this into x plus 3x minus 2. And I will have to immediately state two restrictions. Can anyone tell us which restrictions need to be stated? Negative 3 and? Very good. So now I move this fraction to the other side. 6 over x plus 3 minus 5 over x minus 2 plus 20 over x plus 3 x minus 2. What is left on the other side? 0. Again, you can come up with variations of this method. You can change the method. You can look in the book and see that they are doing slightly different step. They're multiplying both sides, blah, blah, blah. I think that that is more difficult, but that may work for you. It doesn't matter what I think. What is the best method for you, that's the one that you should be using. Okay? So now I have to find the least common denominator. If I omit the equal symbol and 0, I'll change it into an expression I will never solve. So what is the least common denominator? All different factors have to be in the least common denominator. It's a must. So then if x plus 3 was multiplied by x minus 2, the numerator has to be multiplied by the same quantity. If x minus 2 was multiplied by x plus 3, the numerator has to be multiplied by the same quantity. And the last one, the denominator is the same, so I will just say I'm multiplying by 1. Thank you, Damon. So then I have to multiply these. So 6 times x, 6x, and minus 12. I have to multiply these. Negative 5x and minus 15, and then plus 20. Is this okay? So now we have to combine like terms. I have 6x minus 5x, which is x. I have negative 12 minus 15, which is negative 27, plus 20 is minus 7, over x plus 3, x minus 2 equals 0 over 1. This just tells us that this is now was changed into a proportion. And only in a proportion I can.
Cross multiply.
Very good. And then I get what? Equals 0. This product is 0. So therefore x equals 7. Any questions? Kelsey, is this okay?
Yeah,
Okay, very good. It's an important type of equation. Yes, Lindsay, you wanted to say something?
Yeah, I have another equation.
Yes.
X plus 5 over x minus 2 equals 5 over x plus 2 plus 28 over x squared minus 4.
Good. So what type of equation is this?
Same rational.
Thank you. Good. So I will do exactly the same thing. X plus 5 over x minus 2 minus 5 over x plus 2 minus 28 over x plus 2 times x minus 2 equals? Very good. Equals 0. Perfect. Next step.
Or x cannot be.
Exactly. It saves us so much grief later if we do that, right? So x cannot equal, or, very good. And now I need the least common denominator. Do you all agree with x minus 2x plus 2? Because it has two different factors in the denominator. They have to be in the least common denominator. Good. So the first fraction needs what as adjustment? It has like x minus 2, so it was multiplied by x plus 2, so I have to multiply the top by x plus 2, correct? So the second one has x plus 2, but it doesn't have x minus 2, so I multiply by x minus 2, right? Are you with me, everyone? Okay, and the last one, I shouldn't even write it, but just to make sure, okay, it's 1. Because the denominators are the same, that's why it's 1. I don't have to multiply or adjust the numerator. So can anyone dictate now? I have to multiply these two. When I multiply two binomials, I use FOIL, right? X times x, x squared. You cannot do that. FOIL, when we say FOIL, it's first times the second times plus first times this. First times the first, first times the second, second times the first, second times the second. Is that clear? Yes? So I have x times x plus x times 5 plus 2 times x plus 2 times 5. Is this clear? Perfect. Now here I'm distributing negative 5. So I have negative 5x plus 10. And the last one, negative 28.
So you said when you put that number 2 up there,
You mean x minus 2?
No, you squared the first x plus 5, then you squared the 5, and just put 1 over 28.
This is not 1 over 28. This is just what it tells me what to multiply 28 by. This is not a fraction line.
Right. I'm sorry.
No problem. Just to make sure.
So then you said x squared 5x. So which way are you going with that? I'm just trying to follow you.
X times 5, 2 times x, 2 times 5. It doesn't matter. You can do x times 2, plus 5 times x, plus 5 times 2. You can do whatever you want.
And then 2x.
This one here,
Right.
negative 5 times x, negative 5 times negative 2.
Okay.
And then minus 28.
Okay.
So is this okay?
Yeah.
So these two go away. Then we have x squared. So this is over 1. X squared plus 2x. and then minus 8 over x plus 2, x minus 2 equals 0 over 1. And then we, very good, we cross multiply. So then we have x squared plus 2x minus 8 equals, very good. All I have to do is factor.
Plus a minus 4.
So there are two options.
Negative 4, 2.
Good. And I would say not so fast. What do we conclude? The only solution is x equals negative 4. Is this better? Good. My pleasure. Anything else? Other questions? Remember, I have office hours before your class. So if you have questions and if you'd like to work with me on anything, please come in as early as possible. I finish my class at 5:30, and I've been sitting here doing some work and waiting for you. Yes.
Square root of 2x plus 5.
She raised her hand first. I'm so sorry. Okay, say it again. Laura, go ahead.
Square root of 2x plus 5 minus square root of x minus 2 equals 3.
Good. This is a radical equation, and it is a more difficult situation than the one we presented last time. Why is it more difficult? Because it has two radicals. That's why it's more difficult. It is recommended, I don't think that this is on the list, but let's do it. It is recommended that when you have two radicals in a radical equation, to separate them. The solution will be the same if you don't, but it's easier if you do. So I'm going to take this term to the other side. So I have the square root of 2x plus 5 equals 3 plus the square root of x minus 2. Since it is a radical equation and the index is 2, what do I have to do to both sides? Right. But if you make the mistake of squaring term by term, like putting square here, and square here, you're not going to get anything. You have to square the left-hand side as one unit, the whole thing, and the whole thing on the other side squared. When I square this, what do I get? Now, before I ask and before you answer about the right-hand side, I am looking for, and I can't find it, I'm looking for our agreement, because I don't want you to say something that will make me cry. I don't have it. So, how many terms do I have to write on the right-hand side? Thank you. First term squared plus 2 times the first times the second. 2 times the first.
76 times the square root of x minus 2.
Very good. Plus the second. Very good.
Wait, but did you? I'm just confused on how you got the 6.
This is our agreement from the first day of classes. The first term squared plus 2 times the first times the second plus the second term squared.
Oh, so the 2 and b.
Exactly.
Okay.
Exactly.
Is that completing the square?
After you add the quantity, you complete the square, but that's the reverse. We're not factoring, we're multiplying. Good. Now, this equation still has a radical in it. This radical has to be isolated. So this has to go to the other side, this has to go to the other side, and this has to go to the other side. So the right-hand side is this. Let's figure out the left-hand side. I have a 2x and I'm subtracting x. What do I get? I have a 9 minus 2. How much is 9 minus 2? 7. I have 5 on this side, and I'm bringing a negative 7. 5 minus 7 is?
Negative.
Good. I completely simplified the equation. Now what?
Divide by 6.
No, because I will have a fraction. I don't want to do that. It's not a mistake. But what is my purpose next?
Okay, X.
To get rid of?
The square.
Exactly. How do I get rid of the square?
You put the 2 to the parentheses on the 2 back.
Which means I raise both sides to a power, which is? I have to square again. I wasn't trying to avoid this particular type of problem last time, but did you find it in the in my math lab?
Yes.
Okay, so my department chose it in my math lab, but I didn't see it in the list. But it's fine. Good. Okay, what now? Left hand side, please.
Plus X minus 2. Or S squared
We have an agreement.
minus 2X.
X squared minus 4x minus 4 plus 4.
Very good. Equals?
36x minus 72.
You're correct, but I just wanted to show it why. So this is a product. It's not a sum or a difference. The product is always easier. I square 6 and I square the square root. Now we distribute. X squared minus 4x plus 4 equals 36x minus 72 indeed. What type of equation is this? Quadratic. How do I solve a quadratic equation?
Equated to 0.
Awesome. So, x squared. Please subtract 36 from both sides. I have a negative 4x and I bring a negative 36x minus 40x. Now I'm adding 72. I have a positive 4 and I'm bringing a positive 72. Very good. We can factor, possibly. Numbers are big. Let's use the quadratic formula. Negative b.
I have a quick question.
Sure.
This may be dumb, but why do you square on the left hand side? Like, you know how you put the 4x?
You mean this one?
No, below. The 4x plus 4.
Yes.
Why don't you do the same for the x minus 2? Yes.
Because it has a square root on top of it.
Okay.
Better? Very good. So negative b plus or minus b squared minus 4ac over 2a. So if you have your calculator, give me the number. If not, I will calculate it myself. And 1600 minus 4 times 76. And the square root. I got 36. So x equals 40 plus or minus 36 divided by 2. What now? So 76 divided by 2. 76 divided by 2 is 38. And 40 minus 36 is 4. 4 divided by 2 is 2. So these are the two options. But I have no clue whether they work. I used the principle of powers. I have to check. It's mandatory. So I go back 3 pages before. It's a long problem. So I copy the original problem. And I plug in 2. 2 times 2 is 4. 4 plus 5 is 9. The square root of 9 is 3. 2 minus 2 is 0. The square root of 0 is 0. So this is a yes. Now I'm checking 38. 2 times 38 is 76. 76 plus 5 is 81. The square root of 81 is 9. 38 minus 2 is 36. The square root of 36 is 6. Is 9 minus 6 3? I have to say yes to the second one as well. I will not put a problem with 2 radicals on a test or work or final exam.
The test come from the book or my
Everything we covered in class and everything that the questions on the list of
but
problems.
not my math lab or the book.
It's the same thing. Everything is the same. This is just, I'm assuming that my colleagues, when they created this course, they didn't check. Because I'm not going to enforce the 2 radicals. It took me 5 minutes. No, it will take you probably 10. So no. 1 radical. Yes, Kelsey?
I have another question.
Right. I will not be able to finish my material, though. So,
Chris, I have a
Be-
question.
I'm sorry?
I have a question on this.
This, yes.
The final state of that last is before the.
Say it again.
Before the quadratic equation,
Formula.
yes, before the formula, yes, that one, we can solve it without the quadratic.
Solve it with 4 methods. Any method you want, as long as you get the same answer, you're fine. Any method, yes. Kelsey?
It's all the equation by completing the square.
Okay.
It's x squared plus 16x plus 9 equals 0.
Good. So in order not to make the mistake of combining like terms with what I'm going to find, I'm going to move 9 to the other side. The middle coefficient is 16. We divide it by 2, we get 8. We square 8, and we get 64. So these are the steps. The middle coefficient divided by 2, and you square what you get. So this is the number we have to add to both sides.
Okay, so you said the middle number, the middle coefficient divided by 2.
Yes, and we square that. So the left-hand side will be x plus 8, everything squared. This is the agreement we made. And the right-hand side is 64 minus 9, which is 55. And then we take the square root from both sides. X plus 8 equals plus or minus the square root of 55. Don't forget the plus or minus. And x equals negative 8 plus or minus the square root of 55. So I will answer any questions. I can stay after class with you if that's the case, but I have to be able to present the plan for today, and also, unfortunately, I have to limit the number of minutes for questions. But I'll be more than happy to stay after class and answer anything else. Okay, yes, other questions, if you have anything quickly. Was this okay?
Yeah.
So these are the steps. So we're adding, but
Can you just go over 16, 8, and 64 again? I'm sorry.
say it again.
Can you just go over how you got 64 and 16? Or-
16 is the middle coefficient. I divided by 2 is 8. I have to square it. This is 64. This is the first term squared plus 2 times the first times the second plus the second term squared. This is the contract we made. And this changes into this.
Okay.
Here I add, I get 55. And I have to take the square root, and I have to put plus or minus. Any questions? Any questions?
That number say 55 right there? You said square root of 55?
64 minus 9 is 55.
Okay.
Yeah, and then we take the square root from both sides. Good. So I don't want to rush you, but is there anything else that you wanted me to look at? Okay, so let's start with, we have not looked at chapter 2 at all. Okay. In chapter 2, we have to look at 2.1 through 2.5 before we take our first test. Okay, so we start with 2.1, which deals with functions. The entire chapter is about functions. So this is basically refreshing our memory on what functions are and what characteristics they have. This should not be touching, I'm sorry. My paper's shifted. So this is a scenario, this is a second scenario, and this is a third scenario. So let's analyze this. In this first scenario, I'm just making up stuff. So I'm creating a correspondence. This number, whatever number you want it to be, corresponds to this. This number corresponds to this. This one corresponds to this. This first set of numbers is always the values of x. This second set is always the values of, very good. And I created the relationship. The relationship is normally denoted by f, or in other words, f of x, where x is the independent variable. You can call it v of t, like volume of time. You can call it p of r, like pressure, function of some function, some independent variable. All these are function notations. Function notation. Okay. Now, is this a function? I already told you it's a function, but how come? Why? Why is this a function?
Because it doesn't repeat itself. It doesn't correspond to x.
Each x corresponds to only one y. Each x corresponds to only one y. Each x corresponds to only one y. That's why this is a function. I'm going to create a second scenario like this. This number corresponds here, and this number corresponds here. Is this a function? No, because I showed that to one x value, it corresponds to different y values. It's not a function. It exists. It's called a relation. This first set is the set of x values. This second set is the set of y values. A third scenario. Is this third scenario a function? Perfect, because each x corresponds to only one y, each x corresponds to only one y, and each x corresponds to only one y. It's a function. Now, there is a difference between scenario 1 and scenario 3. They are both functions. This one, scenario 1, has a property that 3 does not have. And here's the property that I'm talking about. If I decide to go backwards, if I decide to, let's say this is x and this is y, can I create a function? To each x, only one y. To each x, only one y. And to each x, only one y. Can I create a function going backwards? That's why this function is called one-to-one. Meaning, even to one y, to each y, it corresponds only one x. Even the reverse is correct or possible. Now, what about here? Is this function one-to-one? Can I create a function going backwards? The answer is no, because to this x, I will have two y values corresponding. So I will say not one-to-one. Its inverse exists, but it's not going to be a function. That's why this is considered one-to-one. It will have an inverse function. This one is not one-to-one. It will have an inverse, but it will not be a function. That's the difference between these two. This difference between these two is not part of this test. It will be part of the next one. But since I had them here, I couldn't resist to explain the difference between those two. Okay. Now, what is the name of this set? In all scenarios, values of x, but it has a specific name. Awesome, very good. Indeed, domain. And it also has specific name for all the other ones. Very good. Range. So the set of values of x is called domain. The set of values of y is called range. Very good. So I think this is my page 4, and this is my page 5. Okay. Very good. I would like to look at a graph now and identify the domain and range. I'm looking on page, if you have your book, so you don't have to. I'm looking on page 231, and I'm going to copy a graph from there. Something similar. So we are on page 231. I'm making one up. Okay. Is this a function? How do I know?
Vertical line test.
Well, awesome. By the vertical line test, this graph represents a function. By the vertical line test, what does the vertical line test say? So if I draw a vertical line, I see it crosses the graph in one point, and I will be reading only one y value. For this one, it crosses only in one point, and I will be reading only one y value. That's why this is a function. Perfect. I have tons of questions here. So number one, the graph is a function by the vertical line test. We already have that. Number two, I'm asking you to give us the domain and then the range. What is the domain of this function, and how we determine the domain?
Is
0
0.
to
Is 8.
0 to 8. So let me refresh your memory on how to determine the domain. From the leftmost point for x, when x is 0, till the rightmost point, which is 8. Since at 0 the function does not really exist, I will be using a parenthesis, 0, comma 8. This is a full point. I will be closing it with a bracket. This is the domain. Any questions? So from the leftmost point till the rightmost point concerning x. Now what about the range? Exactly, from the lowest y value all the way where the function exists till the highest y value. So from -3, comma 3, brackets, parentheses. Yes, a bracket at -3 and a parenthesis at 3. Awesome, very good. Next one. Question number 4. Find the zeros of the function. What does that mean? It means the x-intercepts. It's an important terminology to know. The zeros of a function or the x-intercepts mean the same thing. Does this function cross the x-axis?
2 and 7.
Very good. And in the ordered pair format, can you give us the ordered pairs, anyone?
2, 0, 2, 7. I'm sorry, 7, 0.
Very good. Awesome. Say it again. 2 and 7. Very good. Okay. So number 5. Local max min. What is this? Local max, local min. Let me explain and we'll come back to the problem. So here's an example. Here's a graph of a function. I'm just making this up. Would you agree that for any x value to the left of 5, the function is increasing? So between negative infinity and 5, the trend of the function is increasing?
Yeah.
Good. Let's say this is 10. Would you say that between 5 and 10, would you agree that the trend of this function is decreasing? From some value to some value, I don't care. But between x equals 5 and x equals 10, obviously the function is decreasing. Would you agree?
Yeah.
So now from 10 to infinity, would you agree that the trend of this function is to increase its values? Very good. Now, this point is called a local. Some books call it relatives, same thing. What? Indeed, very good. Thank you very much. Local or relative max. Why? Because I can show that all points, so I can show an open interval around that point where the function exists on both sides, it's a must, and all those values are smaller than that one. I can show an open interval where all values are smaller than that one. So that's why this 5 comma blah, whatever you want it to be, let's say 3. 5 comma 3 is a local or relative max because I can show the open interval. What do you think this will be? 10 comma negative 2. Can I show the open interval? The function exists on both sides and the values are much larger than that one. How do we call this? Yes, not a minimum, but a relative or local, whatever you want, one or the other, minimum. Now, what about this situation? Let me come back. I can come back here. This appears to be maximum, right? It's the maximum possible value. First of all, it does not exist. So it can be. Secondly, can this be a local maximum or relative? No, because I cannot show you the open interval. The function doesn't exist on one side. So even if this were a full point like this one, even if it were a full point, it would have not been a local max or min because the function does not exist here. Now, what about this one? Is this a local max? No, because the function doesn't exist on this side. So what does this function have when it comes to local or relative max min? Only? Exactly. So it's right here. Because I can show the open interval, all these function values are higher than it. So 1, 2, 3, 4. So can anyone give us the point that represents not a local max, but a local min? 4 comma negative 3. Which one is the actual min from these two? Of course, it's the y value. Where is that found? For what x value? Exactly. So the minimum is obtained, or is attained if you want, at 4, but the actual value of the minimum is -3. So we have to be able to differentiate between these two. So when we're asked, where is the minimum? At 4. How much is the minimum? -3. When I say how much, I'm asked about the y coordinate. When I'm asked where, I have to say when x is 4. How much? -3. Okay? Good. Now,
Is it the same thing as the vertex?
the vertex is specific for the quadratic function, and no other function has a vertex. Yes. This is potentially a quadratic function, but I'm not given the whole function. I don't have the expression, so I can't say it's quadratic. It could be a portion of a cubic function, like this. I don't know. So I cannot call this a vertex unless I'm told you are given a quadratic function, then that would be the vertex and it would be a minimum. Very good question. 6, intervals of increasing or decreasing. So let's go back to the graph of this function. And I see the trend. I see that between 0 and 4, the function is decreasing. We're not interested from which value to which value. We're only interested in the trend. Between 0 for x equals 0, and x equals 4, the trend is decreasing. What is the trend between 4 and 8?
Increase.
That's all I have to write. So I will say f decreasing on the interval 0, 4, f increasing on the interval 4, 8. Any questions?
What's that little thing before the first parentheses? Is that M?
On.
Oh, okay.
Sorry, you don't have to write it if you don't want to. On the interval, I should have said. On the interval. And remember, these are for x values. This is just the trend. It does not, when we're asked for the intervals of increasing or decreasing, we're not asked to say it increases from 5 to 10. No. We're asked about the trend. So it's increasing between x equals this and x equals this. We don't care from what to what. And it's decreasing between this and this. Okay?
I have a question.
Yes, please.
Those particular notations, they do not require brackets. They're just parentheses.
Perfect question. Excellent question. The reason why we do not put brackets, it's because at 4, the function is not increasing or decreasing.
I'm just curious.
You're right. You're right. So we do not put brackets for the trend. Yes. Very good. Next question. Number 7. Is this function symmetric? What is that? Is this function symmetric? There are two. Say it again.
Does that mean like, I
Are they
don't know.
divided equal?
Say it again.
Maybe a line and divided into two equal parts.
I think you are referring to the graphs of two inverse functions. We're not there yet. Yes, Kelsey?
I think I have the same thing. 2 halves is the, I don't know.
No. So there are two, but I think you're thinking about the same thing. There are two types of symmetry for functions. A function can be even or odd. If it's even, it's symmetric, WRT, with respect to the y-axis. And if it's odd, the function is symmetric with respect to the origin. We will look at two graphs, one from each, and we will draw a conclusion in a minute. Very important conclusion.
Yes, I included that right there, RT.
With respect to.
Oh,
With respect to. Now, why would I even care whether a function is symmetric or not? You will see in chapter 3. If a function is symmetric, it's so much easier to graph. And I don't need a lot of information about it. If it's not symmetric, it's not symmetric. I have no choice but to dig deep and get a lot of information about it. But it's nice when graphs are symmetric. Very nice. Okay, so let's look at a graph. Here it is. From the way I graphed it, what would you say? What type of graph is this?
Quadratic.
Correct. But I'm saying with this symmetric with respect to the y-axis or symmetric with respect to the origin? Of course. I can even show you this. That's why I love writing on paper. I could have not done this with a board, right? Could I have done this with a board? Just kidding. Of course not. So now follow my explanation, please, because this is a relationship that we have to discover together. Okay, so let's say I have an x here. I don't know what it is, and it doesn't matter what it is. So can anyone give us the coordinates of this point? Of course, this is function f of x. I can't. I'm talking about x. I can't.
The X.
X, comma.
2.
No, I can't.
1.5.
I can't. No numbers, please.
Why?
Right. Y. Correct. But there is another way of writing y.
F of X.
Thank you. Very good. Now forget about this for a moment. I will go exactly opposite on the other side. And I'm going to say this is what? It cannot be x on this side and x on the other.
Negative X.
Very good. Awesome. And I go up. It crosses in one point. And I would like somebody to give us the coordinates of this point. I specifically cover this so you don't get biased by that.
That's negative x, 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 negative x.
Very good. Perfect. So now let's take a look. They are symmetric. I picked x and negative x, or negative x and x, right? So I went up to the function. And then what happens here with these two values? What can you say about f of x and f of negative x?
Same Y value.
Of course. So this is the relationship. F of negative x must equal f of x every time a function is symmetric with respect to the y-axis or even. This is the key relationship. We're going to work on this in a minute. I need to show you the other one first.
So
Say it again.
I want to say it means y equals to y.
Y,
That
that is coming from f of x
Yes.
equals the y that is coming from totally different thing that is f of negative x. I agree. Totally agree. Very good. So let's take a look at this one. Here's another graph. And I'm going to give you a couple of hints. If I connect this point through the origin to this point, this line segment must equal that line segment. If I connect this point through the origin to this point, from the origin to this point, this line segment must equal the line segment from this point to this point, from the origin to this point. Is this function symmetric with respect to the y-axis? Can I fold it with respect to the y-axis? No, not y. But it's symmetric with respect to,
X.
very good. Symmetric with respect to the origin. Stay with me. I'm going to create 2 points because I need the relationship. So here's my point. This is my x. Go up. Can anyone give us the coordinates of this point?
X.
Very good. Of course, I'm going to the other side. What is this? Very good. Can anyone give us the coordinates of this point?
Negative X. Fx.
That's why I covered it, so you're not biased by what we just wrote.
Fx. Negative Fx.
F of X.
F negative X.
Yes, I agree. Very good. So now, in the previous case, we had this, right? Right? Where f of negative x was equal to f of x. No y, there is no need for y. We were talking about f of negative x equals f of x. But now I have this. What is the relationship between this and this? What is the relationship between this number and this number? They can be equal, right? So what is the relationship now between this and this?
Take inverses.
Exactly. This number is the opposite of that, or this number is the opposite of this. They're not the same, but they're exactly opposites. So I'm coming back, and this is the relationship. F of negative x equals the opposite of f of x. I didn't forget what we were doing, but I want to give an example of this. Say it again.
I'm just trying to write it down.
Yeah, it's this. Yeah, I just copied it twice. I copied it here so we have it summarized, and I also wrote it here. F of negative x equals negative f of x. Okay. So let's say I have the function f of x equals negative x cubed plus x and minus 3. I'm asked, is this f of x symmetric? What does that mean? Well, I'm asked whether it's odd or even. Can I find the function that is odd and even at the same time? There is one. The x-axis. But who cares? Only y equals 0, or if you want better, f of x equals 0. This is the only function that is odd and even at the same time. But who cares about y equals 0? No one. So there is no function other than this that is odd and even at the same time. So if I discover that this is odd, I don't have to check whether it's even. If I discover that it's even, I don't have to check whether it's odd. And if none of the above, then it's not symmetric. So what do I have to determine? What do I have to determine if I want to see whether the function is even or odd?
Plug in values.
No. Specifically, which value? Look at these two relationships and you'll say, I know you have to calculate fx is the function that is given. I don't have to calculate it. What do I have to calculate? What am I trying to calculate? What do you think? This is given. This is given. What am I trying to calculate? If this is given and this is given, what is the only thing I need to calculate?
Function of negative x.
Of course. This is what I don't have. That's what I need. Very good. Thank you, Harry. So let's find f of negative x. Very good. So how do I find f of negative x? I look at the function. The function says f of the variable is minus the variable cubed plus the variable minus 3. How do I find f of negative x? What do I have to do?
Locate f negative x on the graph for the value.
You pick a value for x, but the negative.
No, I just replace it. So remember this function. Very important to remember this. This function of whatever is negative whatever cubed plus whatever minus 3. Now my whatever is negative x. So then this is negative x, this is negative x, and this is negative x. If I'm asking you, for example, find f of 2, how will you find f of 2? Right, but now I'm asking you to find f of negative x. Same thing. I copy the minus. This gets replaced by, in parentheses, to the third power, plus, very good. That's it. This is what I have to simplify. Now, if it equals this, what do I conclude about the function? If it equals the function itself, what do I conclude about the function?
Even.
Correct. Then I have to calculate, if it's not even, I will calculate the opposite of f of x. Assuming this is true, what will I conclude about the function?
Odd.
Correct. What if none of them works?
Not symmetric.
Not symmetric. Exactly. Good. So how much is negative x to the third?
Still negative x.
Very good. With minus in front.
Plus x.
Very good. So this is x cubed. How much is positive negative x?
Negative x.
And then minus 3. So now I have 3 questions for myself. Exactly what we just discussed. Does this equal f of x? If you say yes, then it's even. Does this equal negative f of x? If it's yes, then it's very good. Or none of the above. So I'm looking at the original function and I compare it with this. Are they the same? Are they the same? This one is negative x cubed, this one is positive, this one is positive, this one is negative, and this one is still negative. Are they the same? No. Function is not even. Now I have to find this piece. How do I find negative f of x? What do I do to both sides of this equation to find negative f of x?
Change the sign.
Multiply both sides by negative 1. So multiply here by negative 1. multiply here by -1, positive, multiply here by -1, and multiply here by -1. Now the question is, are these two identical? No. What do I conclude about negative x cubed plus x minus 3 then?
Not symmetrical.
Not symmetrical. Because it's not even, bless you, and it's not odd. Any questions for me? Any questions? So coming back to my graph that I invented a few minutes ago, is this function symmetric? Can I fold it on the y-axis? No. Is it even? No. Is it symmetric? What I have here, do I have a copy here?
No.
So it's not odd and it's not even. So what I have here, do I have here? No. So it's not odd and not even. Very good. Okay. I would like to do two more things. One is talk about piecewise defined function. One application of this from real life situation. Can anyone, and you can say you haven't even explained what it is. It's a function that is defined in pieces. If x is between blah, 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 I have a function. If it's between this and this, I have a different function. If it's between this and this, I have a different function. So have we ever encountered something like this in real life? We all turn in taxes, right? Before April 15th. I don't know anything about the new code. I have no idea. But in the past, for someone earning between 30 and 50,000, there is a function that gives us the result of how much we pay. For somebody who's in the next bracket, there is another function that gives us the tax return, the tax bracket, or the tax amount we have to pay. For people, there's another function. That's a typical situation for a piecewise defined function. Bless you. Okay, I will pick a problem from page 252. Let's say, I don't like any of those, but they are on page 252, so I'm going to make one up. So f of x equals 2 minus x for x less than or equal to 1, and 4x plus 1 for x greater than 1. Is this a piecewise defined function? Yes.
Mm-hmm.
How many pieces does it have? 2. Now I have to draw your attention to something very important. To the left-hand side of 1, there is one function. To the right-hand side of 1, a totally different function. This function cannot be extended on this side, and this function cannot be extended on this side. They are on their own planet, if you want. They cannot cross each other. What do I have to do or find first when I'm asked to graph? This is the question here, graph this piecewise defined function. What is the first thing every time you give me, you throw at me, back at me, a piecewise defined, any function, I forgot